Hey everyone, and welcome to the second state of the community for the OpenMined project. I am Patrick, and I'm here with our fearless leader, Andrew. We are going to be going over a couple project updates today, as well as a demo there at the short end. But first, we will go over some updates in the community. In particular, today, right, Andrew? Today is our 2-month anniversary of the project.
Yep.
Yep, today. Great. So starting today, and we hit either 499 or 500 members in Slack, unless somebody quit in the last few seconds. So 500-ish members in Slack, so that's fantastic. And we've also got 38 code contributors at this point. So that's fairly impressive for a young project. So what we're going to be doing today is just a quick 10 to 20-minute call. We'll be going through updates on the project, as well as a walkthrough of various projects that are going on right now. And then at the end, as mentioned, Andrew has a demo, an update for us. So we'll start by discussing PySift, and we'll give a definition, the current status of the project, as well as next steps for the project, and maybe also some help needed, Andrew, if you'd like to include that, some calls to action. Then we'll be going into Sonar and PySonar projects, and then finally ending with Capsule and the demo of that project. So with that said, Andrew, go ahead.
Awesome. So yeah, so it's been another great couple weeks. If you remember, the last update that we gave was our first kind of release, or first milestone, which was the hydrogen milestone, and kind of a lot of projects all sort of finished at once. So what I would like to do during this this update is really just to give a fresh perspective on 3 of our biggest repositories, on kind of relative to maybe the intro video that you might have seen, where we are today and what the next steps are for these projects, so that you kind of have a little bit of context for where we are in the progression towards the general vision for these different libraries. So the first one we'll talk about is PySift. So if you don't know PySift already, it is our encrypted tensor machine learning implementations, right? So it's got 2 main things going on. The first one is it's several different tensor objects, each which should have nearly identical functionality. The main one, which most of you are familiar with, is tensor base, which is basically our decrypted tensor, and that follows along the API of a popular library called PyTorch. And what we're doing with our new tensor libraries, and really this is where we get into kind of the next steps for this library, is we want to build out identical functionality, but with different homomorphic encryption algorithms as the backend. So we want to have, right now we have a Payer tensor, which I'm sure you've already seen, and some of you may have already used. And then we want to move forward into a Yashi tensor, Aono tensor, and BV tensor. And those are going to be based on the homomorphic encryption libraries that we also have within the OpenMined community. So when you think about PySift and as a library, think about it as 2 things. First, as a collection of different tensor objects, each of which allow you to do basic tensor operations with a different homomorphic encryption backend. And the second one is a collection of machine learning implementations. Now, if you look in there right now, what you're going to see is kind of the basic linear model implementation, which just gives us sort of a template for what types of functions we need to be able to call on all of our machine learning models, and we've used it in some of our basic demos and that kind of thing. However, the next step for this set of half of PySift is going to be implementing some basic automatic differentiation technology, so that then we can also move into doing more general machine learning algorithms, right? So that's kind of the state of the PySift project. And if you look in the issues, most of them are going to be focused around upgrading either our kind of new tensor classes with new homomorphic encryption backends, or building our first kind of automatic differentiation, either wrappers, either using someone else's automatic differentiation, or building our own, so that we can then start prototyping some kind of higher order, more complicated machine learning models. The second project I want to do a little bit of an update on is Sonar and PySonar. So if you don't know, Sonar is our collection of blockchain smart contracts which manage the federated learning environment in OpenMined. So basically what these smart contracts are supposed to do is sort of oversee the training of machine learning models and ensure that people are compensated fairly based on what gradients they're contributing. And PySonar is the Python client that allows you to actually interact with the Sonar blockchains when they're deployed. Now, the current status is basically the basic demo for federated learning that you saw last week, right? Where we have a predefined data set, which is the diabetes data set, and we have a predefined model, which is the linear model from PySift, right? So the great thing about the demo we had at the first state of the community was that it was the first time we could actually run the whole system locally, right? And we could have individual miners who are mining a local test blockchain, and anyone can pull it down and run it with Docker and break it apart and see how the platform is running. However, you can't train on an arbitrary data set. You can't train an arbitrary model. You can't do all the normal things that we want a data scientist to be able to do, and you can't upload new parts of the schema. So the sort of next generation where we want to see Sonar, PySonar, and also Mind.js move to is where we're not tied to kind of a prepackaged demo data set, and we're not just tied to a linear model. So when you're thinking about kind of scopes of work and when you're reading tickets, contextualize that as sort of we've got a basic, simple toy version working, and now we want to start maturing it and building out these different features that people are going to want. And finally, I want to talk about Capsule, which is probably the fuzziest project that we have, or the fuzziest repository, in that there's been so much conversation with relatively small amount of code to sort of anchor us all to the same piece of functionality. Now, in the first original video, Capsule took the form of kind of an insurance policy, right? And at the time, that was our kind of leading idea for how to distribute risk. But since then, Capsule has taken on a significantly more flexible and useful paradigm within the platform. And that is anything that is not obvious to decentralize in an early edition of the project, we're putting in Capsule as a sort of mental exercise, right? And also as a tool for testing and developing the rest of the platform. So right now, in the demo I'll show you in a minute, Capsule is taking on the role of basically saying, okay, there are various parts of the platform that we think could be vulnerable, right? So for example, we are debating different ways in which we can store and protect private keys, right, for various homomorphically encrypted tensors, right? We're also trying to answer the question of, okay, how do we efficiently clean out the noise in these tensors, which in some cases you have to have the private key to do. So what we're doing right now is we're putting that into Capsule and saying, okay, step one for figuring out how we're going to decentralize these problems is just to put them all in one place so we understand what the constraints are, right? And also so that it doesn't bottleneck the development of the other pieces that we do understand. We just need something to test against. So when you think about Capsule, I want you to first think about it as the place where all of the insecure things go, right? So if you see a vulnerability, we're going to throw it into the Capsule project, and the team that's focused on Capsule is there to try to handle and work out these problems and figure out what combinations of algorithms are going to work best. To that end, there has been a tremendous amount of progress in making this happen. And if you're watching the original video and are curious about sort of the insurance policy and the various weaknesses, like check out the backstory in Capsule, check out the document, the Google Doc, which we can upload a fresh version of, and you'll see a significant amount of progress in the thought work on making the platform secure. So without further ado, I actually want to give a quick demo on Capsule just so you can see the kind of functionality that we're building into Capsule so that it's clear why it's useful. So now I'll share my screen. Just the application window for Google Nest. You're going to see. Okay. Patrick, can you see my screen?
Yep, we're all good.
Awesome. So this is going to look a lot like normal interacting with Sift. So if you know Sift, you create these. So in this case, this is a vector of ones, right, which I multiply times 0.2. We can just say ones, okay, base tensor, right? Now, when we homomorphically encrypt one of these tensors, right, using our public key, get a paleo tensor, right? So y2, right, we'll say that. Now we have a paleo tensor, and this thing is encrypted, right? Now I do a bunch of mathematical operations in this tensor. Eventually, we're going to get to the point where I can't actually decrypt this anymore, right? So if you're familiar with homomorphic encryption, we have this notion of noise growth, all right? So now, one of the questions that we have is, okay, that the primary way to be able to get rid of the noise is to actually decrypt this object again, right? It's called this dot decrypt, right? Make this out the original answer. However, the ability to decrypt something is incredibly special, and we're not entirely sure where we want to put that yet. So what we're building into Capsule is just a simple RESTful server that gives you the ability to generate key pairs such that the private key is hosted on the server, and instead of me being able to actually requiring the person who has this tensor to also have a copy of the private key to do decryption, when I call this decrypt, this local Django Capsule client actually runs out to this server where the key is hosted, right? So when I originally created these two objects, right, I asked the Capsule to create a public and private key pair, right? So this creates public and private key, but it only sends me the public key, right? The private one stays hosted inside of Capsule, right? So now when I create these encrypted tensors, right, I can encrypt it because I have the public key, but I cannot decrypt it by myself. Right? So when I create these tensors, right, I've got X is encrypted and Y, which is not encrypted. Because I have the public key, I can encrypt things, but I can't decrypt things without having the private key. But we don't want me to have the private key because it could be a security violation of one kind or another. So what we've built is instead of requiring every person who has a tensor to also have the private key, we're hosting it inside of Capsule, right? So Capsule generates these keys and never gives up the private key throughout the entirety of interacting with it. And if I want to decrypt something, right? If I want to decrypt something, I say X dot decrypt. I can treat this CC object, this pointer to my Capsule as a private key, and it will function as one. But in the background, it's actually calling the Capsule server and asking it to perform that for me. So now you might ask, okay, what's the point of this? The point of this is that it means that it decouples the ability, it removes the ability to decrypt something from necessarily having to be the person who creates the keys, right? So I was able to create a public and a private key pair in such a way where I don't actually own the private key. All that is to say, this was part of a security vulnerability, and instead of doing a big build out, we've implemented a simple server in Capsule to address it. And yeah, so now how do I unshare my screen? There we go. Awesome. So that was a little bit convoluted, but the takeaway that I hope you come away with is that Capsule is not a specific thing at the moment. It's a catch-all for any security vulnerabilities that we see in the platform, and it's a set of useful tools that allow us to circumvent those security vulnerabilities while we're building out the rest of the platform. And it's also a place to have conversations on how we can best solve those. This is just one example of a security vulnerability that we are not going to allow to block the rest of the development of the platform because we now have this simple server in Capsule that's going to address it. Does that make sense?
Yeah. How many, in theory, how many capsules would there be, and who maintains the right to run a capsule specifically?
Yeah, so if we were to actually deploy, a test network with a Capsule, there would have to be some sort of hosted server, most likely, that ran Capsule. But for now, the point of Capsule is I can have a local Capsule running that sort of abstracts away difficult issues like who owns public keys and private keys, so that I can further do development locally, right? Because that's kind of the main activity that our community is focused in. We don't have a live blockchain solution yet. But Capsule could also grow up to be sort of an early version while we have a test network of sort of a black box that yes, we know that there are security vulnerabilities if anyone could hack this box, but we've sort of addressed it in the short term so that we can facilitate the development of the rest of the platform. Because otherwise, it would bottleneck the rest of development waiting on these sort of outstanding issues when we don't want that to happen. So that's the idea behind Capsule.
For a lot of people who are viewing this, they've probably viewed the introduction video, which, by the way, minor unofficial update, we are working on a second and more concise version of that introduction video. But for the now, it is deeply ingrained with a good bit of knowledge and the philosophy behind OpenMined. Andrew, how similar is what we're doing now in terms of Capsule to what is described in that video specifically? How much has it changed over time very much?
Yeah, so it's changed quite significantly, which is kind of why I wanted to make sure that we addressed it in this video. The notion of Capsule just being an insurance policy where things are put at risk is now it's just sort of one idea that can be a part of the Capsule project, but it's not the end all be all of how the system is going to be secured. So there's about 4 or 5 different ideas on the table, several of which are secure options, and we're going to evaluate multiple to see which one is the most performant. So check out the Pi Iono homomorphic encryption for kind of this key rotation strategy. You can hit up myself or Mayank, talk about why key rotation can be so useful for solving similar problems. We're also looking into multi-party computation as a really great and performant solution for solving some of the same issues that the Capsule did. So, and I think it's probably a little bit too long for us to address in this video in full depth what those ideas are, because they are deeply technical and not really relevant to much of the audience. What I do want you to know is that Capsule is no longer just one idea or one solution. It's a system of it's an ecosystem of tools and a place to have conversations around the most difficult parts of the project.
Awesome. Well, I think that does it. If you guys want to find us, you can of course join the Slack channel or find us on openmind.org. Andrew, anything else?
I don't know if you mentioned this. Today's our 2-month birthday. Oh yeah, you did. You mentioned that. Yeah. So super excited to be 2 months old and to have 500 people hanging out in Slack and 40 people having pushed code. So very excited with all the progress. Lots of great pull requests this week, and yeah, check out the announcements page if you ever want to see what projects are going on at any given time. I've been updating that pretty religiously, and I will continue to do so, just so that everyone can see kind of all the different projects that other people are working on at any given day. So awesome. Other than that, that's good for me.
Sounds good. Thanks, man.
All right. See you later.
Bye-bye.